The tropical rainforests of Central and South America hold the most densely packed, fiercely competitive ecosystems on Earth. Survival here requires absolute efficiency. Deep within this environment lives Paraponera clavata, commonly known as the bullet ant. Measuring between 18 and 30 millimeters, it ranks among the largest ants on the planet. Its thick black armor and massive jaws give it an immediately intimidating presence. But those jaws are primarily for foraging. Its true weapon is located beneath its abdomen. Unlike many ant species that rely on biting, the bullet ant drives a hidden stinger deep into the skin to directly inject its venom. The physical effects are instantaneous. Within seconds, a localized burning sensation expands, causing rapid, uncontrollable muscle shaking and intense radiating agony. Despite measuring roughly an inch long, this insect has developed a biological deterrence so severe that it instantly neutralizes predators thousands of times its size. To understand exactly how severe this deterrent is, entomologist Dr. Justin O. Schmidt intentionally subjected himself to hundreds of insect stings, creating a standardized metric known as the Schmidt Sting Pain Index. This chart illustrates how everyday stings stack up. A typical bee sting registers around a 2, and a paper wasp hits about a 3. The bullet ant earns an off-the-chart score of 4+. Schmidt recorded the sensation as pure, intense, brilliant pain. He famously likened it to walking over flaming charcoal with a 3-inch rusty nail embedded in your heel. Yet, despite inflicting pain that endures for up to 24 hours, the venom rarely poses a lethal threat to healthy humans. Victims suffer intensely, but they survive. Why would an organism expend precious biological energy to engineer a complex venom that maximizes agony, only to leave its target alive? While snake venom typically breaks down tissue and muscle to kill prey, the bullet ant instead utilizes a highly specialized neurotoxin called ponerotoxin. Ponerotoxin attacks specific sodium channels within nerve cell walls. Normally, these gates open and close to regulate signals. The toxin jams them permanently open. The nerve cell cannot shut off, firing a continuous, relentless loop of extreme pain signaling triggers a massive physiological cascade. Victims experience severe localized burning, a rapid heartbeat, violent muscle spasms, and even temporary paralysis. This unyielding neurological storm lasts for a full 12 to 24 hours. Once it finally subsides, the victim is left exhausted, but completely free of permanent tissue damage. This enduring suffering serves as a psychological deterrent. By inflicting unforgettable agony without killing, the ant permanently rewires a predator's behavior, ensuring it will never attack again. The psychological impact of this biological defense is deeply understood by the Sature Mawe people of the Amazon, who incorporate the bullet ant into a traditional cultural rite of passage. For this initiation, hundreds of live ants are carefully collected and temporarily sedated using natural herbs. They are then woven into special gloves, with their stingers facing inward. Young boys entering adulthood place their hands inside these gloves and keep them there for roughly 10 minutes, enduring dozens of simultaneous stings as the angry ants awaken. When the gloves are finally removed, the trial continues. The initiates endure hours of intense, lingering agony, violent shaking, and temporary paralysis in their arms. Enduring this ritual stands as a profound test of human resilience and courage, serving as living proof of just how flawlessly this ant's biological defense mechanism operates. The bullet ant demonstrates that in the natural world, precise chemical engineering often outmatches raw physical size or brute force. Now, modern medical science is attempting to borrow that exact engineering. Researchers are actively studying the venom to understand its unique properties. Because ponerotoxin precisely manipulates nerve signaling, scientists use it as a biological tool, mapping exactly how the human body transmits pain on a molecular level. By reverse engineering the venom's specific mechanisms, they hope to develop highly targeted treatments for chronic pain and severe neurological disorders. This creates an unexpected biological irony. The insect uniquely evolved to cause the greatest known agony may eventually provide the key to stopping it.